Hi, this is Aaron Jerome at Jerome Electronics, a YouTube channel. Just taking a little side bunny trail. This is a little short video about, well, I forgot what it's about. Let's see. It's about voltage producing components, generators used in series and parallel. Up to now, we've been talking about hooking up components in series and parallel, and you can also hook up voltage producing components, which we generally call generators. I guess in a way capacitors are more of a storage than it is a producing, but this would be like I don't know, solar panels, windmills, batteries, generators, things like that. So far we have been talking about components. So these little zigzag lines like on Charlie Brown's shirt, those are resistors, and they don't have to actually be resistors with color bands. They can be like a toaster, a vacuum cleaner, and a light bulb. But they have been components that have been consuming electrons, and we want to talk about maybe putting producing components there like batteries. Okay, so I just want to, think back. This is a series circuit because there's only one path for electrons. There's no choices for the electrons. They have to go through, every electron has to go through every component. Kirchhoff's series laws, if you remember, this is probably the way that Kirchhoff's laws are generally stated. I call them KSLV, KSLR, or KSLA and KSLR. But this is the mathematical way of saying that KSLV is simply add them up. KSLA, if you know one, you know them all. KSLR, add them up, which is the way we learned. Might need Ohm's law here. And of course, so we're putting one of those there. And so this is also a parallel circuit. And parallel circuit means that there are different branches, different pathways for the electrons to travel through. The electrons then have choices. And using Kirchhoff's parallel laws here, this is KPLV, and this is how we say, if you know one, you know them all. And I said KPSL. I think it's KPLV, if you know one, you know them all. KPLA, add them up. And of course, KPLR, this formula, which we just call the wonky formula. We've talked about all of this stuff in the past already, but I want to talk, I'm just bringing us back to the context of this little bunny trail I'm on. So in this case, we're putting producing components, electron producing components. They're not producing electrons. Electrons are electrons. But they are, I guess we should call these voltage-producing circuits. And we're putting a generator here. A battery is a form of a generator. And, of course, being a Time Lord, I know the battery of the future is going to be called a NukiBat, a nuclear-powered battery. And so let's say that this NukiBat gives 1.5 volts and 0.004 milliamps. If we put another NukiBat in line here, and notice that's negative to positive and not positive to positive here. We put another NukiBat here in series because there's only one direction for the electrons to go. This one will also produce 1.5 volts, and it also pushes out 0.04 milliamps. And if we put a third one in, same thing, 1.5 volts and 0.04 milliamps. So what happens? Well, this is a series circuit, so in this case, the series laws apply. So that means if we are calling these producers that are not consumers, if they were consumers, we'd call each one, what each one consumes, a voltage drop. But then that means this would be a voltage raise. And KSLV for voltage means that the voltage would be increased by adding up the voltages of each of the batteries. The amps, on the other hand, are going to always be the same in a series circuit. Components, if you know one, you know them all. That means it's going to be a 0.04 milliamp circuit. So What did we learn? Batteries in series, they ramp up the voltage. Amperage is the same. What about parallel? Parallel circuits. Again, choices. The electrons have choices here. And instead of those resistors, we're going to put in Nuki bats. This first Nuki bat gives 1.5 volts and 0.04 milliamps, just like before. So does this one, and so does this one. Okay. And if we want to know the total voltage, KPLV says, if you know one, you know them all. Notice that all of the positive sides, the bump on the top, they're all connected, whereas in the series, negative was connected to positive. These are all the negatives are connected to each other, and all the positives are connected to each other. KPLV, if you know one voltage, you know all of the voltages, so that means that the voltage total will be 1.5 volts. Amps, on the other hand, are ramped up this time. That means we're going to add 4 cents, 4 cents, 4 cents, 4.04 milliamps times 3, that's 0.12 milliamps. And so what did we learn here? Batteries in parallel, that ramps up the amperage. Voltage is the same. Series ramps up the voltage. Parallel ramps up the amperage. Now I have a question for you. This hookup, series or parallel? Just pausing to let you think about it for just a second, but look, all of the pluses, all of the positives are all connected together. All of the negatives are all connected together. Are we ramping up the amperage or are we ramping up the voltage? Look back one slide. Look, all the positives are hooked up to the same wire. All the negatives are hooked up to the same wire. This is a parallel connection, right? What about this one? You are jump starting a car. Do you hook it up in series or parallel? Well, we're hooking up the positives together. We're hooking up the negatives, although the negative on the left is hooked up to a piece of metal somewhere in the car rather than the battery. But it's the frame of the car, the chassis of the car, is the ground. The negative of the battery is just hooked to the chassis of the car. This is a little bit safer way to hook it up. This is the way we jumpstart, and it is parallel, not series. There are problems if you hook it up the wrong way. If you connect positive to negative on the two different cars, what you're going to do is ramp up the voltage. Voltage, too much voltage in a vehicle is a bad idea. Lots of things can happen if you hook this up wrong. So remember, when you're jump starting a car, it's always red to red, positive to positive, black to black, negative to negative. And so what goes wrong? Well, too much voltage can harm different components of the car. It can harm the battery, it can harm the old alternator, all by over-voltaging these things. Too much voltage, too much electromotive pressure. It could mess with the jumper cables, the car electronics, the fuses, the sensors. Luckily, there are fusers in there, so most of the time, doing it accidentally, just don't crank it over. And if you do crank it over, make sure everything in the car is turned off. And probably it can be recovered from, but it just means greater cost, more money. In some cases, it could be dangerous. But anyway, that's the end of my little bunny trail. When you jumpstart a car, connect all the positives to positive, all the negatives to negatives. This is a parallel connection, and that is the safest way to jump your car. End of my little bunny trail soapbox speech.